Hello, welcome to Maths with EJD. We are still talking about generating functions, in particular probability generating functions. That's looking at generating functions in probability. Previously, we had introduced ourselves to the idea of probability generating functions. So here, let's talk about moment calculation from PGFs. Okay, so generally speaking, right, here our focus is to calculate moments. Here, we set out to calculate moments. Interesting, moments are basically expectation, which you can also see in the line of uh mean in it technically. So you have their moments are expectation and variance. Expectation and variance of a random variable, of a random variable using its probability generating function. That's what we basically want to do here. So now talking about moment calculation, then we need to understand that for the first moment, which is expectation, first moment. So the first moment is that corresponds with the expectation of the random variable. Okay. So for that, it's the formula is simple. You're looking for the expectation of x, which is the first moment, right? That's gx prime evaluated at s equals 1. That's the first moment. Then we can also talk about the second moment. The second moment. So the second moment corresponds with variance. That corresponds with variance. And in that case, we have the expectation. So for variance, right, you're going to have let me see. So of course, to get the variance, we need to okay, yeah, the second moment which can enable us get variance, right? But the focus itself is on the expectation of x squared. That is the second moment. But you know, the variance itself is actually, if I remember, variance of x is actually, I think, expectation of x squared minus expectation of x. Okay. So, but this is actually the expectation of x squared is actually the second moment. Okay. It's the second moment. So that's why the focus is on that. So, I mean, knowing the first and second moments, we can easily calculate variance. That's basically the idea here. So expectation of x squared is equal to gx prime prime, more like some kind of second derivative, gx prime prime evaluated at 1 plus the first moment gx prime evaluated at 1, basically. So those are the two moments we need to calculate. So um just like in the previous video, the question we used there, we are going to use the same question right here. So let's look at that question again as we consider our example. So given the given the PGF, given the PGF gx of s, this is what we obtained in the previous example. G of x equals 0.2 plus 0.5 s plus 0.3 s squared. So given this PGF now, um, calculate calculate the expected value, calculate the expected value and the second moment and the second moment of x and the second moment of x. Okay. Now, talking about the solution, we just invoke the formulas and we keep going. So for the solution now, we know that the first moment is expectation of x. So expectation of x is simply gx prime, gx prime of 1, right? So the first moment is gx of 1, right? So expectation of x here is gx of 1. We know that. But before we talk about gx of 1, we are simply saying that gx of s itself already is 0.2 plus 0.5 s plus 0.3 s squared. So the first moment here is simply telling us that we just need to evaluate gx of s where s is equal to 1. So expectation of x is actually gx prime of 1. That means this expression, just bring it. We have 0.2 plus 0.51 plus 0.31 squared. So that is 0.2 plus 0.5 multiplied by 1 plus 0.3 multiplied by 1. So all of this now is simply um talking about first moment, right? So that would be this evaluated at 1. So trying to see what's this. Ah, okay, yes, 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 yes. So before we do the evaluation, the prime is the prime means derivative, right? Okay, yes. So we need gx prime evaluated at 1, right? So we can go back and say gx prime of s is simply differentiate 0.2, you get 0. Differentiate 0.5 with respect to s, you get 0.5. Then differentiate 0.3 s squared, you just get 0.6 s, okay? 0.6 x s. So gx prime evaluated at 1 is simply 0.5 plus 0.6 multiplied by 1. So that is 0.5 plus that is 0.5 plus 0.6. So gx prime evaluated at 1 is actually 1.1. So gx prime of 1 is equal to 1.1. So you can say, therefore, the first moment is gx prime evaluated as 1, that is 1.1. So that's the first moment. Now we go for the second moment. That's the expected value. The first moment, is this, which is this is also the expected value. This is also the expected value. Expected value. That's the first one. So then we go for the second moment. Okay, so we found the expected value, which is the first moment, the second moment of x now. So to find the second moment of x and the second moment of x, we know that is simply expectation of x squared, which is given as from what we had before, gx prime prime evaluated at 1 plus gx prime evaluated at 1. So we know already that gx of s is equal to 0.2 plus 0.5 s plus 0.3 s squared. So we need to differentiate twice because this is first derivative, gx prime, just one derivative here. This is two derivatives. So gx prime of s is 0.2 is constant, so it goes. Then you have 0.5, then you have 0.6 s. Then we need the second derivative, gx prime prime of s, that is simply 0.6 here, 0.6 as 0.6. So if we take it further, right, we know that this implies that gx prime evaluated at 1 is 0.5 plus 0.6, and that is 1.1. Then here, this implies that gx prime prime evaluated at 1, it's already constant, so nothing changes because x is no longer part of that. So that's 0.6. So we can say, gx, therefore, expectation of x squared is equal, which is the second moment, is actually um the expectation of x squared, which is the second moment, is actually gx prime prime evaluated as 1 plus gx prime evaluated at 1. So this is 1.1 plus 0.6, and that is 1.7. Okay, we can say therefore the second moment is expectation of x squared, which is equal to 1.7. So if for whatever reason you now need to find the variance, you have everything you need to find variance. So this is like an extra. Let me just say extra to find variance, variance, to find the variance, we have variance of x, and that will simply be expectation of x squared minus expectation of x all squared, I believe. So expectation of x squared now is 1.7 here, minus expectation of x alone. I think we got 1.1. Okay, that is 1.1, 1.1, and we can square this. Yes, I think that is it for the expected value of x. Yeah, 1.1, So of course, this is expectation of x. So it's 1.1. So if you need variance for whatever reason, so this is now 1.7 minus 1.1. This should be 1.21, I believe. Yep. 11 times 11 is 121. So this is 1.7 minus 1.21. So in case variance is required, which is this is just an extra, like I said, this is 1.70, 1.21. So this is 9, this is 5, I believe, and this is, or this is 4, yeah, should be 4, and that's it, 0.49, yeah. So 10 minus 1, 9, 7 minus, so 6 minus 2 is 4, then 1 minus 1 is 0. So the variance is 0.49. If that is required for any reason, the variance is 0.49, if at all that is required. Okay, so that's that for moment calculation from probability generating function. So if you're given a probability generating function, of course, it is a function, right? So you can differentiate it a couple of times. So it has to be differentiable for it to work in this situation. So that's that here. So, and that's the second part of the application of moment generating functions in probability. In the next video, we'll be talking about probability generating function of the Bernoulli distribution. Particularly, Bernoulli distribution is a particular, is a special type of distribution and probability. So you don't want to miss that. So subscribe and hit the notification bell so you can always get alerted each time a new video is released. Then comment, let me know how helpful this video is for you. And let me know if there's a topic you'd like me to teach or a problem you'd like me to solve. And like and share so that more people can have access to this great learning. Till I come your way again, have a great time. Bye.